Hello, Assalamualaikum everyone. I'm Sumaya. Okay, let's proceed with our third session for the Master in Internal Medicine SPSS workshop, online workshop. Okay, for this session, I will talk about normality tests and also univariate analysis. Okay, so for normality tests, there actually are two types or two methods on testing the normality of your data distribution. It's either using a visual graphical methods or using a numerical method, using the normalities of numerical methods. So um, for visual and graphical methods, there are several types of graph that you can use. It's either histogram, okay, or box plot, or statement leaf, and also normal QQ plot. Okay, so usually what histogram show is actually the curve, the bell curve. So we always expect that the data lies within the mean, right? So we always expect a curve shape. For the box plot graph, usually we can have a look at on the outliers. So here you can see the data point, and actually it's provide the number of case. Okay, and then the stem and leaf. Stem and leaf is actually a tilted histogram, 90 degrees to the right. Okay, and also the normal QQ plot is where we can see the data point lies on the line. Okay, for numerical methods, it's either using Kolmogorov-Smirnov and Shapiro-Wilks, or skewness and kurtosis. Okay, the Kolmogorov-Smirnov usually is for the bigger sample size, while for Shapiro-Wilks it's for the smaller sample size. So if you have about 50 and below, okay, you should use the Shapiro-Wilks instead of Kolmogorov-Smirnov. Okay, for skewness and kurtosis, usually the range is between negative 1.96 to positive 1.96. Okay. Actually, I have uploaded steps on how to do a normality test in my YouTube channel. Okay, so you can just Google it yourself and have your sweet time to watch it. Okay. So okay, after we've done our normality test, it's time to decide for statistical analysis. Okay, this is where we connect the dots. Okay, for this type of variable, what type of statistical tests involved? For this type of objective, which tests are appropriate, and how can I present the data? So this is the questions that you need to ask yourself before conducting the statistical analysis. Okay. So basically, there are descriptive and inferential analysis. So for the first one, the descriptive analysis, we would like to measure the central tendency and also the spread of the data, or we can also say call as dispersion. Okay, so the measure of central tendency is usually for medical research. We always report the mean, okay, and also the median. For the spread or dispersion, we would like to know the standard deviation for the mean, okay, and usually for median we present together with interquartile range. How about variance? Variance is actually a square of standard deviation, so it's enough to just report standard deviation with the mean. Okay. For the non-normally distributed, usually we report median and interquartile range. Okay. So this is the step for descriptive analysis. So just go to analyze, descriptive statistic, and click frequency, and then move your variable to the variable box. Okay. Usually we only choose the to measure the central tendency, all that we use the continuous variable. But if you just want to see the frequency, like want to see the percentage, we just put it and tick display frequency the tables at the bottom of this uh, pop-up pop-up table. Okay, and then we need to click on statistic. As this is the continuous variable, we would like to know the mean, median, and standard deviation. So just tick. So the interquartile range is within the quartile value. So you need to tick on quartile. Okay. So dispersion is under the standard deviation and variance is under the dispersion. Okay. So you can also have your own sweet time to learn how to conduct the discrete analysis. I have uploaded the video in my YouTube channel, so please have a look. Okay, for the second test, which is for the second analysis, which is inferential analysis, we would like to know whether we are going to use parametric test or non-parametric test. Okay. So we all, after you done your normality test, so if you found that your data is normal, you can actually proceed with parametric test. But if your data is not normally distributed, the plan B is to do the non-parametric test. Okay, so parametric test, usually we would like to compare mean, okay, because it's continuous variable, right? So we would like to compare between groups, or if you have two groups, it can be an independent t-test. If you have more than two groups, it can be one-way ANOVA. Okay, so the between two groups or two time point, we can do paired t-test. If the same people but you measure twice, it can be a paired t-test. Okay, if you measure twice, three times point, you can be an ANOVA test. Okay. Then the alternative for comparing mean, we should compare median, okay, by using Mann-Whitney test. So Mann-Whitney test is the substitution for t-test, Wilcoxon for paired t-test, and Kruskal-Wallis for ANOVA, okay, respectively. Secondly, we would like to correlate. Okay, we would like to correlate between two continuous variables is either using a parametric test or non-parametric test. The parametric test we call Pearson. The non-parametric test we call it as Spearman. Okay, and then if you move forward, you can do regression. Okay, so this regression involves multivariate analysis, which we won't actually talk about it in this session. Maybe in the future session we will elaborate more on regression. It's either linear or logistic. Why is it linear is under parametric test? Because we have the assumption of normality of the distribution of the outcome, but the logistic regression, there is no such assumption, and then the outcome, it should be a categorical variable. Okay, so it's like either dichotomous or ordinal. Okay, first one, cross tabulation. Cross tabulation is actually one of the non-parametric tests. It's also known as contingency table analysis, where we use a categorical data. So it should be a nominal measurement scale. What is the example of nominal? It's like ethnicity, what else? Severity, right? Okay, so it's a nominal measurement. Okay, so two or more dimensional table that record frequency. So it can be more than two. So I got question, quite a lot of question. If the category is more than two, can I use cross tab? The answer is yes. Okay, and then the test involved is chi-square test. It's either Pearson chi-square test or Fisher exact test. What is the difference? I will between these two, I will elaborate more after this. Okay, so this is the cross tabulation step. So usually we will visualize our table first. The column will be the two groups, okay, the followers and non-followers, or if you have three groups, you can put in the column. But for this example, my column table will be followers and non-followers, okay, and then the other thing should be the rows. So first thing first, we go to analyze descriptive statistic and click cross tab and move all the visualized table, okay. So the rows will be the thing we put on the rows, okay. So ethnicity, gender, heart disease, okay, and then the column will be followers and non-followers, okay. So next we click statistic, okay. So statistic will come up this option, then you tick chi-square, okay, and then click cells, okay, click cells. So it will display percentage, row, column, total, tick column, okay. You just want to know the column percentage, because we should always aim that the column percentage we add up, it must show a 100%, okay. So this is what I mean. The column percentage, when we add up, it will come up as 100%. Okay. So this is the output of cross tab. You should have case processing summary to see whether there are any missing data. And then you also got the cross tab table and chi-square test result. Okay, so the p-value is actually the asymptomatic significant two-sided Pearson chi-square. Okay, so the 0.288 is the p-value. So what you want to present in your table is actually the percentage of male on percentage on female. So usually we put as 47 in bracket 29.4% like that. Okay, so the result here showed that there is no significant association, or there is no significant difference in the for the between the gender and false variables. Okay, and then this is the 4x2 table. Okay, so as I said, it is possible to run a chi-square test for the categories with more than two groups. Okay, so but the outcome will be slightly different, where there are no Fisher exact test option here. It's only provide you the Pearson chi-square test. So when are we using a Fisher exact test? So this is example of Fisher exact test. Is where your table, okay, you have 50% have expected count less than 5. Okay, so usually we choose Fisher exact test in a small sample. Okay, so this is usually happen in smaller sample. Okay, like here, it is very uncommon to get heart disease. Okay, so it's only 6 out of 105. Okay, so if you have this kind of statement under the table of chi-square test and the percentage is 20 and above, choose Fisher exact test instead of Pearson chi-square test. Okay, next, correlation. So it is between two continuous variable. So for cross tab is between two categorical variable. Okay, it's either two group or three group. It doesn't matter. It's between two categorical variable. But here for correlation, the analysis is between two continuous variable. Okay, so the output is either positive correlation or negative correlation. Okay, so usually we would like to display the correlation using the scatter pie chart. So you can see the line, is it decrease or increase. Okay, so that's indicate the correlation. So the decrease mean negative correlation, the increase one will indicate the positive correlation. Okay, how are we going to run the correlation? So you go to analyze, correlate, and bivariate, and then put both a scale measurement, continuous variable into the variable. And if your data is normally distributed, use Pearson. If it is not normally distributed, use Spearman. Okay, just click OK. So this is the outcome. Okay, usually Pearson correlation table provide the asterisk to indicate the significant correlation. So here we can see that there is significant negative correlation between age and BMI, meaning that with increase in age, their BMI is actually decreased. Okay, so if your data is not normal, you can opt to the Spearman's row output. Okay, so just report the p-value 0.09. Okay. For the correlation, usually the acceptable one is 0.3. So even though this is significant, the correlation is actually quite low. Okay, so 0.7 is excellent, 0.3 is acceptable. Okay. Next, compare means. Okay. Compare means is actually when we have one continuous variable and one categorical variable. So example here, do follows BMI is the same as the non-follows. Okay, so that our null hypothesis is then there's the average BMI does not differ. So usually the null hypothesis is always neutral, does not differ. But the alternative hypothesis, the average BMI differ. Okay, so mean BMI of follows is not equal to mean BMI of non-follows. Okay, so this is the distribution. Move on. Okay, so the independent sample t-test, again we should is the between one continuous variable and one categorical variable, but when you have two independent groups in the categorical variable. Okay, so example here, you would like to compare mean of each group between male and female to see whether there is gender differences in the continuous variable, which is here is the depression score in the DAS 21 score is just an example. Okay, so how to run the independent sample t-test? You just go analyze, compare means, and independent sample t-test. So always remember to just put your continuous variable, the ruler icon there, okay, on the test variable. So you can't put any categorical variable there. Okay, and then the grouping variable, we should put the groups that we want to compare. So example here, I would like to compare the age of fallers and the non-fallers. So the group of falls, I put in grouping variable, and you need to define group as 1 and 0, or how it depends on how you code your data. Okay, so this is the output of independent sample t-test. Usually they provide you the group statistic for mean and standard deviation. So the first table is actually important for us to get the information to be put on on the table. Okay, so next is the independent sample test table. Usually if we got this result, we go to the Levin test first. Okay, so if the Levin test is significant, we could not use the first p-value here. Okay, the equal variance assumed. We cannot use this one because our Levin test is significant. Thus, we need to use the second one. The equal variances not assumed. But if your learning test is non-significant, you can use the first p-value here. Okay. So this is how we read independent sample test output. Okay. How to report? So this is how your table will look like. Okay, usually we put characteristic and then we put the two group and also the p-value. What we will report is actually the mean and standard deviation for the normally distributed data. Okay, so here we found that followers were significantly older and had poorer physical performance as compared to the non-followers. That is how we interpret the output. Okay. Next, one-way ANOVA test. So just now the t-test is between one continuous variable and one categorical variable. The one-way ANOVA test is also the same, but we have more than two groups in the categorical variables. Okay, so here, example is when you would like to see the ethnic differences in the depression level. Okay, so you have the first group, Malay group, second group is Chinese group, and the third group is Indian group. Okay, so we would like to compare all these three groups, who has the highest mean score of depression or who has the lowest mean score of depression. Okay. So to run one-way ANOVA, you just go to analyze, compare means, and one-way ANOVA. Okay, put your continuous variable in the dependent list table, list box. Okay, and then the factor, you put your ethnicity. Here we don't need to define our group. Okay, so don't worry about that. And then click option and tick on the descriptive box. Okay. Next, click on post hoc and then click either if you want to know the using the LSD, warfarin, or Tukey. It depends. Okay, all are correct actually. Okay, so this is what the outputs look like. So you have the descriptive. So again, descriptive is important for us to get the information that we would like to display in the table. Okay, so here there are mean age for each ethnic. So Malay age 71.89 with standard deviation 4.6, Chinese age 73.84, Indian age 76, others age 73. Okay, and then we can SPSS will provide you ANOVA table. This is the ANOVA table. The most important here is the SIP column. Okay, this is the p-value for your ANOVA test. Okay, so here is 0.002. Okay, so just now we had tick on the post hoc. So this is the post hoc output. The objective of post hoc is actually to do a pairwise comparison. So just now we know that across ethnic group there is significant difference on age, but who is the most where is the significant as post hoc actually provide the information. Okay, so here in the post hoc table, similar to correlation table, they actually provide an asterisk, so you can see that asterisk under the table, the mean difference is significant at the 0.05 level. So here you can see that using Tukey HSD, Malay is actually younger than Indian. Okay, that's how we read the table. Okay. And how to report ANOVA, one-way ANOVA especially. Okay, so this is from my publication. Okay, so actually look at three groups. Okay, so either non-OA, asymptomatic OA, and symptomatic OA. Okay, so there is actually significant different across group. And then to mention about the pairwise comparison, I actually used indicator like asterisk, the yen symbol to show the pairwise comparison. So that's why I put there asterisk significant in pairwise comparison of nano-A versus symptomatic OA. The yen symbol significant in pairwise comparison of symptomatic OA versus asymptomatic OA. So this is how we describe the table. So please take your sweet time, your own sweet time to read and digest this table. Okay. So I think that's sum up my presentation on the normality test and univariate test. So we learn the normality test, how to conduct, okay, and then the descriptive analysis, okay, how to measure central tendency, what is the values, mean, median, mode, and also the dispersion, the standard deviation, and also interquartile range, okay. And then we did learn on the inferential analysis. Okay, what is the substitute of for the parametric test if our data is non-normally distributed? Okay, like the comparing median and also Spearman, and also we learn about correlation. Okay, by Spearman and Pearson, and then cross step the non-parametric test, the contingency table test, okay, between the categorical variable, okay, and then we learn about independent t-test, okay, for the two groups. This is the most common test we use, okay, independent t-test, and if we have more than two groups, we will opt to one way over test, okay. So that sum up my presentation. Uh, Thank you for listening.